Hello, everyone. It's great to be here. So my name is Mackenzie, and I'm a security and developer advocate at GitGuardian. And I'm going to be talking on my topic, which is going to be the growing problem of secret sprawl. So I'm going to explain what secrets are, what is secret sprawl, and why it's a growing problem. So good place to start, just to get everyone up to speed, is what are secrets? So when I'm talking about secrets, I'm referring to digital authentication credentials. And that's a fancy way of basically saying anything we don't want someone else to have. So these can typically be things like API keys, could be encryption keys, could be security certificates, could be passwords. And an important differentiation with these and other kind of what you might be hearing about in machine identity is that these include both machine identity and human identity. And this is in no way an exhaustive list of everything that a secret is, but it gives you the idea, right? A secret is something that is going to authenticate you or grant you access to services, to data, either machine to machine, human to machine, or any other kind of combination of that. So secrets are really the crown jewels of our organizations, and we definitely don't want these getting into the wrong hands. So how do we use secrets? So this is kind of interesting because it's very different in how we build modern applications, right? There's been a big shift in how we build modern software applications. So it used to be that we built these monoliths, right? Everything that we needed for an application to run was internal to it. And that software didn't have to connect with other services, it just ran. But that is not how we build software today. So here's a very simple example, an oversimplified example. But let's say we're building an application. We have our application there on the screen. And our application is rapidly going to become a collection of different services. I like to use the example of credit card processing, right? Are you going to build out your entire credit card processing system? You're going to go through complicated bank regulations to be able to make that happen, complicated storage of sensitive information, or are you going to use Stripe or PayPal or some other service? So we can extrapolate this to lots and lots of different things. Yes, credit card processing, but also maybe instead of building search functionality, we're using Algolia. Maybe instead of managing our own databases, we're using a managed service. Maybe we're using Twilio to send messages, MailChimp to send emails, all these different things, right? So that we can focus on what our application does. But this isn't just for our application, this is also for infrastructure, right? Because now we need to host our infrastructure. Are we going to build our own servers, or are we going to use AWS, right? Probably AWS. We need to manage our source code. We need to test our application. We need to deploy our application. All of these things that sit in our infrastructure are also separate services. All right, so now that we've built our application, we have it hosted, well, we still have all these different services that we've created, like little microservices that our internal application uses. So these might not be third party. We might create these, but they still require authentication so that we know who's connecting to them. And then finally, the pesky marketing and sales teams are going to want dashboards and insights into what's happening into the application. So they're going to connections with Salesforce and other CRMs or different dashboards. All of these little logos, all of these icons on the screen are a potential access point for an attacker. There's all these different services that are connected, interconnected, and they're connecting and authenticate using different types of secrets. And every one of these can grant access to an attacker to get a little bit deeper into our infrastructure. And quite often you can move laterally between different services. So this is really kind of how we use secrets. So secrets are the keys to the kingdom. Hopefully we can all agree on that. They're highly sensitive because they can give access to literally everything. But these also kind of sprawl through our systems, an unwanted distribution. Now, the number one place where these secrets sprawl is inside Git, inside our version control of our source code. And this is because developers need access to these secrets to be able to perform their job. So, here we have this first trouble of these secrets both being highly sensitive yet widely distributed. That those two don't necessarily go hand in hand to make a nice security pairing. So they often end up inside our source code. What's important to know about our source code is two things. One, everything we do in source code is kept in our version history. So as a developer quickly hard codes a secret to get a system working quickly, even if they delete that later and then it gets pulled into master and there's no sign of that secret to those that review it, that secret's still there in the history. The other thing is that source code is designed to sprawl. It's going to be downloaded onto all your developers' machines. It's going to be shared inside messaging systems, inside internal wikis, inside documentation. It's going to end up inside our running applications, perhaps in our containers like Docker images. And all of this is going to be cloned and backed up in multiple different places. And the key to all of this is we have no visibility. We have no idea where these secrets end up. Once it goes into our version control, we have no logs of who's cloned that, what machines it's on, where it's been backed up to. It just doesn't exist. So this collectively is what we call secrets sprawl, right? I love that word because you can kind of imagine them sprawling through your systems, and that's really exactly what they do. Now, we want them in access control. We want them in vaults and secrets managers. But if they leave, they sprawl through our systems. So I want to talk a little bit about how secret sprawl has affected real life attacks, real life breaches, and then a little evaluation of kind of what's happened in each case. So the first one I want to talk about is Codecov. January was the initial access of 2021. So a little bit about what Codecov is. So Codecov is a code coverage tool. Essentially, it tests how much of your application is being tested, right? It's a test for the test. This does a very specific job. It sits inside your CI/CD environments, inside your pipeline. So when you're automatically testing your application, Codecov might be one tool in there, and it does a very small, very specific job, right? It tests how much of your application is being tested. So it's not necessarily considered this critical application, but it was breached and it was a significant supply chain attack. So what exactly happened? So inside Codecov's public Docker image, if you don't know what Docker is, it's basically, you can think of it as a container of files that an application needs to run. Everything that an application needs to run is inside this Docker image. It's not an actual image, it's just what we call, because it's a snapshot of different systems that it needs to run. So inside their official Docker image, so this is what customers would have used to run Codecov, the attackers downloaded it and analyzed all the code that was inside that. What did they find? They found a plain text secret inside this public Docker image. So this secret essentially gave the attackers access to modify a file. It gave them access to some cloud storage where they hosted a bash uploader script. So this bash uploader script was, part of the application. A lot of organizations used it, and it was a way of automating some processes. They were able to modify this bash uploader script. They injected one line of malicious code. There was about 1,000 lines of code in this file, and that line of code did something very specific. It basically turned Codecov, every single time one of Codecov's users ran that application, it took all the secrets that were being used to build that client or that user's application. So, connections to their databases, connections to their code repositories, and it sent them to the attacker. At the time, 20,000 people were using Codecov, 20,000 organizations, and they included HashiCorp, Rapid7, Twilio, Monday.com, large companies. These attackers were able to gain access into all of those companies that I've just named, all of their internal systems, all of their private source codes, because they got access credentials from Codecov, which they had turned malicious. So here's an example of lots of different things, because we have a plain text credential that's ended up inside a Docker image. We have attackers exploiting that, and then they're able to gain access into more internal repositories. And what we know, because these companies that I just named had to disclose it, the attackers were actually able to find more secrets inside these internal systems. And so they'll be able to move laterally again. So you can understand how secrets can be used from attackers to not only gain initial access, but also elevate privileges and move into different systems, even different organizations. So the next thing that I want to talk about, source code make line. So we've seen huge amounts of source code leaks, right? Rockstar is one that's just kind of happened. We had lots, Samsung, Nvidia, Microsoft all had their source code leaked, or as I like to say, involuntarily open sourced. So what we can get from this is that private source code isn't always that private. And that goes back to that idea that source code is designed to sprawl. So I want to look at one of these companies that had their source code leaked out, and that's Twitch. October of 2021, Twitch's source code was made public. 6,000 code repositories, nearly 3 million total files or documents were leaked into the public, which was everything that Twitch had, from their main systems to the secret projects that no one was meant to know about. We actually scanned Twitch's source code for secrets, and we found over 6,000 plain text credentials inside their private source code. We found 194 AWS keys, so keys to access the cloud infrastructure. We found 69 Twilio keys. We even found 4 Stripe keys, access to payment systems. And this was all in plain text in their source code, and this was leaked publicly. So often companies have this false sense of security that their source code is private, it's behind some authentication, so therefore it doesn't matter if there's secrets inside it. That's not true, because source code doesn't have the access control that we really require. I want to give another concrete example. Now, I talked about like Microsoft, Samsung, and Nvidia. This one here is an article specifically about Nvidia. So a lot of their private source code was leaked, and it was leaked by a group called Lapsus, who were able to get inside all of these large companies' private repositories. And it turned out they were a group of teenagers. So how did Lapsus get Nvidia, who's had significant secrets that were used to sign malware in their source code repository? How did these teenagers get access to it? And the answer is remarkably shocking. Here is their Telegram channel. There was 50,000 or so people on this Telegram channel. This is a post from Lapsus Job, the job admin of the Lapsus group. And he is essentially saying that they recruit insiders at the following companies. So they're looking for people that can get them access to internal systems, to Git repositories, to version control systems. So why is this significant? Well, if you think about who you want to have access to your secrets, your credentials, right? There's very few people that should have access to them. Sysadmins, perhaps it should be, engineering leads, people that are in charge of operations, but very few people should have access to these highly critical systems. If you think of all the developers that then you could have thousands of them. Every single one of those has access to those secrets if they're in the source code. So Lapsus knows this, so they're trying to recruit junior developers or other members inside organizations that have access to these systems that the organization doesn't deem critical, but has all kinds of sensitive information into them. So that's how those companies' source code was leaked, and all that sensitive information. It's not because of some super genius hackers, it's just because we're leveraging on social engineering. So why does this happen? Well, there's quite a lot of reasons really why secrets expose themselves in different ways and how this happens. A lot of it will come down to different things, but human error is a massive one. When we're dealing with developers, we're dealing with humans. And when we're dealing with humans, then we're going to be dealing with some mistakes that happen. It's never malicious, almost never malicious that we see that these keys are leaked, and it can happen to the best of us. You would think that we would find more keys with junior developers, but actually these type of mistakes happen all through the software supply chain by various different team members and various different people. So we have here a quote from Ann Hardy, who's a CISO at Talent, that human error exists, but the key is to be able to be alerted, be able to take appropriate action, when a leak is found. But aside from human error, there are just some other examples of really how these secrets end up exposed. So secrets can be accidentally pushed into the wrong repository. So when we're talking about source code, which is where we find the majority of these secrets, if we're talking about GitHub, what's unique about GitHub is that you may have one account and you may use it for both personal and professional use. That means it's very easy to mix up and push code to the wrong repository. So we see this a lot. We see code that is actually being made public. It could even be on a personal GitHub account, not necessarily a professional account, that is being made public, by mistake. We talked a little bit about the history of source code. So everything we do in our version control is version controlled. It has a complete history. So it's very easy to see the scenario where a developer is working on a separate branch of that source code. They hard code a secret to see it works. They remove it. It goes to code review. There's nothing in there that's found. It goes through, it checks all the boxes. It's pulled into the master branch. But actually, in that history, which is now accessible, there are secrets. So we find this a lot. We particularly find this when a private source code repository is made public. The other area that we find it is that these secrets expose themselves in auto-generated files, so debug logs or other logs. If you're doing a debug of your system, you may dump out information about the environment, may have environment variables, and you're exposing secrets. If this gets version controlled, if this gets captured in with all the rest of the source code, now you've got secrets in there. And no one's really going through debug logs with a fine-tooth comb, to see what's in there. So we can have a lot of sensitive stuff in those files. We also have sensitive files that are kind of on purpose being stored in Git. And in this way, a lot of people are still managing their secrets in Git. Why? Because it's convenient. As I said, secrets are sensitive, but they also need to be highly distributed. So Git is a good way to do that, even if it's a total kind of wrong move for a security perspective. A lot of the focus in companies, particularly startups, we see is speed and not necessarily good security practices. And the other one is that we see a lack of governance and policies. And these two go hand in hand. And it's not about just creating security policies and then storing them in a file somewhere. It's also about being able to kind of enforce those policies and be able to get visibility when those policies are being broken. So governance and policies is a big one. So how do we prevent it? So we have to use the appropriate tools. So we should use key management systems. We should use secrets managers or vaults. We have to use the right tool for the right job. It's important to note that this doesn't necessarily mean that you should be using the most advanced system on the planet. HashiCorp Vault is a great product for large companies, but if you're a company with 10 people, you want to use a system, you want to use a secrets manager that you're actually going to use and that you have the manpower to maintain. That is something that we see a lot, is that incorrectly tools are kind of being used but not implemented properly. We should never store secrets inside our Git repositories, ever. We should never have them in our source code. We need to educate developers on this, and we need to have kind of areas around preventing this from happening. We should use short-lived credentials or short-lived secrets. So API keys can have an expiration date, and other secrets can have an expiration date. And in addition to that, you should have policies around about when these are rotated, so that if secrets are buried in the history, that they're not kind of there forever and maintaining access. If you use short-lived credentials, if they do get exposed, then hopefully they're no longer valid and don't pose a threat. We need to restrict the API at minimal scope. So this means that we don't allow everyone to access everything. We want to control who has access to what, and we need to add automated secrets detection, right? Adversaries are absolutely automating the secrets detection process, so we should be using it too. And this is the area that GitGuardian specializes in. Now, there is a sixth one there. And what is that sixth? Well, it kind of covers everything in here, and that's policies and governance. We talked about that already, right? We need to be able to enforce policies and governance and be able to distribute these widely so that they're not just documents, they're actually practical steps to prevent this from happening. So this is kind of how we can prevent these things. It's a serious threat. It's a problem that nearly all companies are facing, and unfortunately attackers realize this, and it's why these systems are being targeted. I'd like to thank you all for paying attention to this presentation and listen to me ramble about Secret Sprawl. And you can follow me on social media anywhere they allow me to post my opinion. My handle is @AdvocateMac. And if you have any questions for me, I'll be more than happy to answer them or join in the discussion that you may have. So thanks again, and I hope you enjoyed my presentation, The Growing Problem of Secret Sprawl.